over your way in your backyard? What were you barbecuing?
Well, lounge room.
Why don't you tell people who you are? Let's get started there.
Sure.
Don't be don't be shy. You're a very interesting person.
So, Robert Stevenson is my name. I am an engineer, and presently I'm working for Firmus. I should add that I'm not speaking for Firmus, but Firmus is a developer of innovative cooling solutions for data centers, so we can run data centers at a much higher, or sort of much lower PUE, which is power usage effectiveness, which just means that we use less power to produce the same amount of compute, and we spend less of that energy on cooling that other data centers tend to. Before I joined Firmus, I worked in local government, and I was actually working with Pete as manager of smart cities for the city of Hobart, which was a very exciting and interesting role. And then previous to that, I've worked in large wind farm development, energy storage. And then for my sins before that, I worked as a writer and editor in magazine publishing. So there we go, without adding all the taxi driving and other. So that's who I am.
Well, I don't have taxi driving. I do have pizza delivery in
Yeah,
my
but
background, but
I crashed the pizza car once. Sorry, Pizza Hut.
so life after council. I mean, council was a fascinating time. I think, point in time in terms of all the smart city stuff. But do you think smart cities has run its race? Like, what's going on? What are you seeing since you've left?
Look, I think it kind of ran into a bit of a weird period where everyone associated smart cities with surveillance states or something. And then that wasn't helped by, some of the technology, particularly being employed by, some of the Middle Eastern states, for instance. And I think in the same way that, vaccines and health and everything tends to get tarred with a brush, I think smart cities did. I think, if anything, I'm starting to see a little bit of a resurgence now, particularly in the field of Internet of Things. And I think there's been a lot of good press around things like bushfire detection using artificial intelligence engines situated in remote areas, which is not something that can happen, can't be staffed. You can't put people out 24/7 in the middle of the bush. And I think that tech has maybe made people rethink the whole idea of smart cities. I mean, counting the number of people who walk past doesn't involve identifying the people who've walked past, but it can do things like give you insight into where lighting needs to be better and that sort of thing. So I think as the technology evolves and there's a lot more edge processing available with smarter chips and things, that people are perhaps rethinking smart cities. And I've noticed a few cities, coming to us, for instance, to talk about things like digital twins and that sort of thing. Not that that's necessarily what Firmus does, but it's an interesting area.
Yeah, I mean, the digital twin space, maybe I'll come back to that, but I kind of feel the same. Like, there's no doubt the smart city program, when they first came through in the late teens, I mean, I can remember being at the Amazon Web Services event in Las Vegas in 2015, and that was really the start of the commercial Internet of Things stuff that was coming from the big enterprise technology companies, but took a couple of years later before we started to see it come out. But obviously it was very tech aligned against assets, and as with a lot of things in the tech industry, I think we kind of screwed it up as an industry because we just ended up with a lot of technology solving some problems that weren't necessarily the priorities or the strategic problems that cities were having. You know what I mean? And so it was kind of like, but it was really important for the waste technology companies to sell waste solutions, and very important for the lighting technology companies to sell lighting solutions. And they didn't really align or care about that broader strategic intent. And so it was tech led. Whereas now I think we've had some time to digest, and I think you are right that, but also I think maybe the technology has matured a lot as well, where, whereas back then when decisions were being made, the ability to have a single interface or platform to manage all those capabilities in a way that was governable and risk could be managed and the information could be reported on and used and all those sort of things. That was far too sporadic, and there was far too little of that kind of technology as opposed to the easy point solutions that were being sold.
Yeah, and look, I think I remember really clearly from being on the other side, being on the customer side of smart city solutions, that I mean, the big issue has always been integration. Councils and cities and governments have got lots of different systems that produce different types of information and different data streams. A lot of those vendors would come with a solution that might be something like a people counting solution, but their real play was to try to sell you an entire city governance machine. And I don't think that was really ever going to be possible, because what it really meant was that you would have to dispense with all the systems used by all the different divisions around a council and bring them all under some single pane of glass owned by some large multinational. And then immediately that raised sort of issues about trust and data, and the idea that you would be putting all of your data within one corporation's ecosystem. And I found that really difficult. I wanted people to say, here, we've got a great solution that does X, but the data is in an open source format that you can always pull out. We'll give you a dashboard, but if you don't want our dashboard, you can also have your data and do what you want with it. And I think that's probably the way that these systems will grow and become usable, is more small organizations who are able to do that integration piece and bring data from disparate systems and offer it back to you in an open source way, so that you can go back to any large or small corporation. You can put it in Excel if you're comfortable with Excel, or you can put it into any other kind of GIS or data management system, or build your own. You're not, you feel like you're a customer, not someone trying to be trapped into an ecosystem.
But even, don't you think, the biggest challenge is that earlier one that you touched on, where there's so many functional heads inside a city organization, a council. So, and it's about budgets, it's about people, it's about functional control, it's about decision making. And so the biggest thing to overcome is to get everyone to agreement that there's a common good here for something, called city as a service, for that platform to provide information to the customer. Let's not forget the customer. We're sort of talking about the internal political dynamics and roadblocks here, but at the end of the day, cities are there to serve, the constituents, not necessarily a position held by all staff, but that's a difficult one to overcome. So how do you? I mean, it's a conversation with the CEO, and it's a conversation with the directors, and it's a conversation where you're getting all of them at that executive leadership team to agree to something, or at the same time, which is very difficult.
Well, I mean, I think, without sort of giving too much away, that skunk works is kind of the way you have to run it, where you recognize that there's some innovation that will be useful to people in council, to people, ratepayers and councillors and, managers and directors and other staff. But you also recognize that you're never going to get them across the line and get a huge budget to do this thing, whatever it is, whether it's something to do with managing lighting or CCTV or, those kinds of systems, asset management, for instance, just because there's just too many vested interests across council. But if you can produce something that has obvious benefits. And well, I'm sure we'll get back to digital twins, but one example would be building a digital twin of the city, but doing it in a way that's separate from the GIS staff from the city, not necessarily because they don't want to, but because they're busy doing what they're doing, and then being able to present back with something that works and something that's valuable and something that has obvious, you know, value and brings agency to people who didn't know it was possible, because you can't explain it to them beforehand because people don't have time to process it and think it through. But if you can say, hey, look, we just did this one as a trial. What do you think? Suddenly people become, well, they'll join and they will become fans of the thing rather than of the idea of the thing.
Yeah, and I think that concept of it being a thing and not an idea of a thing is a really important point, because at the end of the day, we're creating new assets, and that is something why it's so closely aligned with cities, because cities are essentially asset portfolio managers. That's a large part of that's where most of the money goes, in managing asset portfolios and asset classes. And so, but therein lies the challenge as well, that this is essentially the creation of new assets, whether it's but they're digital assets, aren't they? And that's like, who owns digital assets? What's a digital asset? Isn't that just an IT thing? Well, no, it's not. Well, if it's in my park, then it's a park asset. Well, no, because we're using the same sort of stuff for to do some things in some of the road corridors. Oh, well, that's in the road assets. Well, no, not quite, because it's, you know what I mean? It's so this whole concept of a digital asset is still something that we're transitioning through. I read something, or I saw something the other day that said, whatever this current generation is it Z, or it's not millennial?
I think we're at the end of Z.
It was kind of like they're the ones who are first, where AI are their first cousins or something like that. Whereas we were born before the internet, and so that sort of transition to thinking about everything as digital is only really just happening now. So it's not like, I'm a massive fan of the smart city concept, but from the perspective of what problems are we looking to solve with the potential of the technology that is available to us today to do things in a better way.
Yeah, and look, I mean, I think for me, like, a really key insight when I worked for a city, and it was the first time I'd worked for government, and it kind of took me a while to get my head around, the idea that you had this entity, the city that all these things happened in, that you had to somehow manage. I mean, one insight was, a lot of the interesting parts of the city are things that are so hard that if you put your hand up and say you'll take them on, you get to make a lot of big changes, because nobody else really wants those portfolios. And they include things like parking and lighting and those kind of, highly detailed, often very political, and really complicated, you know, areas of the city. So that was one thing, that if you're willing to put your hand up and do a lot of work, then you can start to sort of see how to make those kinds of changes. But the other key insight for me was, there was a way of simplifying a view of the city where you could just think of it being, and I hate to sound like an engineer here, but you could just think of it like a big time series database. And so at this point in time, 9 a.m. on Tuesday morning, these things happened. And at 9:05, these things happened. And at midday, these things happened. If you have the right kind of sensing information and then the right kind of simplified database behind it, then you can start to sort of pick these patterns. And I mean, we didn't have sort of access to AI tools, which I'm sure would be much better at finding those patterns. But the idea that you can sort of simplify things, it's a little bit like the way you can simplify lots of things down to currency in the economy. You can just say, well, it costs this much, or this one costs that much. Things happen at a period, at a moment in time. And if that thing happened, which might be, a good example that I used to use to explain to people why this was useful, and this is a true example, was that you would have these particular set of lights, street lights in Hobart, would go off, trip off, at sort of regular intervals, but seemingly at random. So suddenly they'd be off. You'd send people to look at them. There'd be nothing obvious what was wrong, and then eventually they'd turn themselves back on again. And no one had ever been able to get to the bottom of it. And we started tracking sort of just a database of when this was happening. And it turned out that it was happening 3 or 4 days after really heavy rain events. So for a human being, it's not close enough to the heavy rain event for you to make that association, because 4 days ago, it's another country. But it would eventually became really clear that, and there'd been a development done on that spot 10 years previously, and they had left a particular kind of, hole in the conduit at some point that could fill up during a heavy rain event, and then you'd get this kind of trip off of the lights. And as soon as the association was made, it was really easy to diagnose the problem. We didn't have to dig up, the entire intersection and everything, and we could fix it. And so we fixed it, and it was then never a problem again. But without that kind of time series thinking, it was just a mystery. The lights would turn off over a whole suburb or half a suburb, and no one could work out why.
Well, that's the beauty of it, isn't it? I mean, that's ultimately the beauty of data and information, where, the end point is that magic 8 ball where you can shake the thing. Why are the lights going out? Rain event. Or, why is the traffic on Davey and Macquarie Street so bad at this particular time? And I remember, like, from a data perspective, it was figured out that the only difference between peak hour and non-peak hour was something like, 400 cars
Yeah.
every, was it 15 minutes or an hour or something like that? It wasn't. So it's all of a sudden it takes it down to, oh my God, this is the worst traffic problem since Bengaluru, to now, actually, how do we solve the problem for 500 cars? Like, and then you can start to think about non-technical solutions to it, but without first having that data and that information in that time series view that you sort of mentioned, and using some of the technologies that's capable, then you're not really in a position to do it. And that I think is fundamental, to it, that there are these multi-objective optimization problems like the MOOPs that are there to be solved, that can be solved with smart cities, but we sort of got a bit distracted, or the industry got distracted by some of these tried technology solutions, which weren't really solving the big problems of the day, that were costing a lot of money or whatever.
Yeah, and I guess a really good example of those is things like the smart bins, where, on the face of it, not a bad idea. When the bin's full, unless the bin's full, so you can come and empty it. But when you think about the way the waste team empties bins, they have a route that they do on Wednesdays. And they go around that route and they pick up all the bins on that route. And you can't introduce a technology solution that says, hey, you can go over here on a Tuesday and over there on a Thursday, because that's where the bins are full. And they'll say, well, we've always done it this way and we've never had massive problems with overflowing bins, which is true.
Yeah.
And so the just seemed like an obvious solution to people. It's a bit like, I remember the people talking about Internet of Things fridges years ago, where, and I don't know if they actually exist or not, but I remember talking to people who were sort of excited about developing them, where it would say, oh, yeah, I can see you're running out of butter, and it would order butter for you. And you think, you've never done the shopping. Anyone who's ever done the shopping, that's not how you do it. You don't want all things to just turn up because they were nearly empty.
Well, that was one of the first use cases that that Amazon actually came out with. It wasn't the Internet of Things fridge, but it was because the first thing they came out with was this button. It was just a button, and the button could be programmed, and the programming in the back end was all the workflow and the code that sat on the cloud. But essentially, the killer app was this button, and it was like a magnet or had a double-sided sticky tape on the back. And this particular one was for the laundry, and their pitch in this presentation, like, we've flown all the way from Australia to Las Vegas, and there's like 25,000 people in this thing, and it's keynote presentation and all, and they're like, and this button, and if you run out of laundry liquid, you press this button and it will order you and deliver you like what's a really sort of popular US detergent brand or something, whatever. Anyway, it was that one. It was like the main one, and Amazon will deliver it to you within like an hour or something. And I was going, yeah, that's the best. And then you think about it, well, you don't you don't drive down the shop or do your ordering unless you've got, your weekly shop or whatever. And then you think about all the environmental impacts of being able to order a single, bottle of laundry detergent because you run out and have it delivered in a truck by a person to your door. And it's just horrific. And it just ran on from there. But if we sort of take a step back, it is the potential of what you can do with that applied to a real problem, which is the beauty of what smart cities always is. So like your waste example, route optimization, like, is still a massive field, but if it's just route optimization for a truck or a couple of trucks for a crew or whatever, take out the fact that that's now mostly outsourced around the country. And so like it's probably a conversation for, Veolia or Cleanaway or whatever it is, most councils. But if it's the route optimization plus it's the reduction in the wear and tear of the tires, and so that sort of pushes out replacement by 4 months, and that has a dollar cost. And then there's the fuel savings, and then there's the carbon emission reduction, and then there's the route optimization, and then there's the, again, it becomes one of those multi-objective optimization problems where if we sort of step back and look at it and go, well, you know what, this could actually save the city X amount of dollars over the next 5 years. It's doing all the mapping of the roads, and so we're getting more efficient at road maintenance and road replacement infrastructure and things like that. And if it's all those things together, that's the potential of it, and that's why it's absolutely magical, because you can do all that with a couple of sensors on a truck and some bins. But if you're just pitching the bins full, or you're just pitching here's a way to optimize your proprietary mapping route data or your paper spreadsheet or whatever it is, it never works, and it's not to. But I think you and I love that dream of there's a big problem here to solve. We've never been able to solve such a multi-objective problem, and they're the exciting ones. Like they're the ones that engineers want to solve. Like, you don't want to solve route optimization for a garbage truck. You want to solve, how do you improve waste management for a whole city? Well, what does that mean? Well, let me tell you what that means.
Yeah. In my mind, when you talked about the button, I just imagined having had toddlers, how exciting to a toddler would it be to run into the laundry and hit that button. So,
Yeah.
and I think the other thing too is that when I was working in that smart cities manager role, in my mind, smart cities certainly involved sort of digital technology, but it wasn't in any way, necessarily associated with digital technology. And some of the things that we did that were the smartest, I think, and whether those things continue now, I'm not sure, but was just to sit down with other people who dug up the road and write some memorandums of understanding to say, if you're going to dig up the road, we'll put some conduit in. And if we're going to dig up the road, you can put some conduit in. Then, over the next X number of years, we'll all have conduit in the same bits of the road, and no one's going to have to dig the road up because they need some more conduit. But what happens now is that everyone individually goes and digs up the road. I need it in March, someone else doesn't need it till May, so that's 2 operations. But no one's kind of able to make, bring that together to be able to say, hey, why don't we both do it in March? We'll bring our stuff backwards and we'll pay into what you're doing. Everyone pays half as much. You still get the conduit in the road. Or we have a lot of conduit in this part of the city and we're not using very much of it. Why don't we share this bit of it with you? You share that bit that you've got over there with us. And as long as we've got an understanding that we're only going to take in at the most 10% of your conduit space or something, leaving you 90, then no one has to dig up the road because we've already done it.
Yeah. Yeah. The partnering between, different GBEs and utilities and, all the other organizations it takes to run a city is definitely one of those areas of potential. But at the same time, and for any normie watching this, there probably a lot of people don't walk around just staring at the footpath and or even notice on a single corner how there's 20 covers for pits existing. And go, why is there 20 covers? Oh, they belong to 12 different companies and they all dig up the footpath at different times of the year. Like no one, but that's the farcical nature of it. And you sort of see it play out. You're seeing it play out with all the fallout of the Spirit of Tasmania project, aren't you? With the thing that just came out yesterday in terms of, well, why are we having to do a $9 million refit on a brand new ship to accommodate for the right type of fenders or something at the Tasport wharf? Well, they didn't let Tasport talk to the
We
ship
didn't talk.
because it wasn't their project. And it's like, come on. It seems like when it's played out to normal people who are citizens of a city and just want efficient services and all the rest of it, it does become quite ludicrous. But that the time series data stuff, and you mentioned digital twins, and that's such a powerful part of the potential of a smart city. And again, but it's one of those areas where I wonder if it hasn't retreated back to uh, the engineering firms. There was some attempt to extract it for the greater good, like to apply against some of these problems, because at the end of the day, to have this data or information, like nobody wants more systems, but if you can have a single pane of glass that is easy for anyone to understand, which is spatially located data against an asset or just a location or like what an event, to be able to do that, then anyone can use that. It's the obviously like the smarts behind that is feeding that data into that spatial environment. But it kind of looks like to me that has gone back a little to the out of the spatial teams and back to the engineering environment. And certainly, if I look at something like all the work that's going in for the preparation of the Brisbane Olympics, or you look at some of the big build stuff that's been going on in Melbourne and Sydney, it's really associated with not with the tech firms, but with the engineering firms. But I don't know. What do you see?
Well, I mean, it's interesting. I mean, there's that whole push towards, Revit being an example, sort of building information management systems where you build the entire build digitally as well as physically. And the idea is that you will have this kind of digital twin of what you've built. You'll have all your as built and that sort of thing in it. And that is very much pushed by the engineering teams. And this is to do things to manage things like clash management, where you don't want the electricians thinking that's a free bit of space and the plumber thinking it's a free bit of space. And then one Thursday, they're both trying to put conduits through the same bit of space, which happens, all the time. But I mean, the interesting thing is that it's just moved that problem down the road a little bit, in that now there's kind of arguments about naming conventions and which format everything's in, and whether your as built digital model is actually reflective of what's there in real life. And it turns out, talking to people who have just completed big builds, like very recently, that's just not the case. They find that the information that they thought was there isn't there, and the information that is there is not necessarily correct. So someone's drawn something, the conditions on site changed slightly, someone moved something, but they never updated that file. So that the place where you thought there was a pier, that's actually empty ground, and the pier is actually here now, which, obviously throws everything out. And then things like assets that are meant to be tagged and placed into the system on the way through, people forget, or it's not really a priority that day. And so all these assets and things, so people have stopped doing a lot of the tracking they would have done previously on paper and stuff because they're reliant on these digital systems. And it turns out the digital systems aren't being particularly well maintained.
Yeah, this is a problem. This is a problem that I see, and it's you're talking about it from an architecture and engineering perspective, but not just civil, but all sorts of engineering. But I see it in pure technology management as well, where up to a point, organizations for for all the complaints about IT taking too long and all the rest of it, there were some fundamentals, some physics to do with IT management, which was you got to get the architecture right. We'll take the time. We don't want to replicate things we've already got. We want to make sure they integrate and all the rest of it. So there's the architecture bit. There was the risk and the governance bit. There's the IT service management, all the ITIL stuff, all the control COBIT stuff, all the control principles and all the rest of it. And then what happened from the early twins was this whole as a service explosion. And then that as a service explosion didn't just make applications and technologies more accessible, not just cloud computing, but really in that sort of software as a service space as well. I term it now whatever as a service, because it's kind of like that's what it is. Like anyone can buy anything. But in doing that, what we also did was we assumed that the architecture and the governance and the metadata and the risk and all that kind of stuff was still being done. But it wasn't, because now you're just getting that particular piece of technology as a service. You don't get all the architectural smarts. You don't get all the governance practices and all the risk management that sort of comes with what used to happen when these things were developed for an on-premise, rollout or by your own sort of internal department. And I think the same thing sort of applies then to what you're talking about, where this assumption, like there's still processes that we need to go through when you're building things to make sure that everything is done right. And whether or not it's getting to the point where your as constructed information is making it into your spatial system or whatever, your project management system, your asset management system, whatever it is, that seems to be a similar sort of problem where all of a sudden it becomes that digital twin isn't very good, or that technology, that application is not doing what we want it to do, when in actual fact it's the person and the process and the workflow in getting that information into the system, which is the problem.
And often people, I mean, I think there's a lot of skill and sophistication of writing and reading contracts at the start of a project, because a lot of people, just assume that something is going to happen because it kind of says it in the contract. But and this is, I find this more than anything with data. People sort of say, well, we want access to the data. And the supplier can say, yep, sure, you'll have access to the data. And people think, okay, that's good, we'll have access to the data. But then there's nothing to say that every month they won't send you a PDF with the data. And I've seen that from things from council where you have access to the data because they print it out and sent it to you, or they print a PDF and emailed it to you. But that's not what you meant. What you meant was, I need constant live access to the data to use in my own way. And then when you say that's what I meant, they say, oh, that's not what we meant. But that's kind of a level of sophistication that's really difficult for, most people who are working in local government who aren't kind of aware of even how the data is formed and how it's stored and how it's captured and how it might be streamed.
There's some sophistication too from the suppliers. Let's not absolve the suppliers from the fact that suppliers data is worth something, and if we give it to them in a PDF version, they'll have to come back and ask for more.
100%. Like, it's not necessarily innocently done, but similarly in building projects, the last bit of the last bit of the contract is often around wrapping up all of that data and giving sort of the as built, the asset plans, the asset lists, and all that sort of stuff. And in order to make sure that that's done, that's often tied to the last payment, but it's usually only a very small payment. So it might be sort of a 5% of the total payment, which is a lot. But if you're the construction company and you've got to either put resources into pulling together this information to get 5% of the last contract, or doing the 80-90% of the next contract, which is where the real money is, suddenly there's no one available to do that bit, and they get strung out. So customers end up with, the notion that they should have good asset management plans and good sort of, listings of assets and where the POs are and all that sort of stuff. But often that's just lost in someone's email and no one's pulled it back together. And even though they're sort of foregoing some part of the payment, it's still not worth their while to put their sort of best people back on it to pull that documentation together. And so, the customer ends up with a building that they don't necessarily have all the information that they expected to have, because it's still tied up in all of those kind of process bits that happened when everyone was making the real money.
Yeah, and I think, digital twins are a team sport, like anything. It requires the architects to be doing their bit, and the engineers to be doing their bit, and the service providers to be doing their bit, and the IT teams to be doing their bit, and the different asset managers to be doing their bit. And this, again, sort of becomes the challenge of seeing these things through to reality, that it's not, these aren't IT projects, as you sort of point out. These are sort of potentially transformational initiatives where if you had the sort of information about any of your assets or your organization, at your fingertips, what could you do? But like more than that, because I think even in talking about that, we're talking about, some older approaches and older technologies that councils especially, but just organizations have to realize that this is the new baseline. Like, it's the new benchmark, because what we're actually talking about, without having any of that in a centralized place, that, even if you've got multiple systems that they're integrated, that the quality of the data within those systems is good, then the ability to be using artificial intelligence and machine learning and things like that to be, either staying in touch with service competition, or to just be able to improve things, and even like if we're talking about AI, there are plenty of, it's not about AI taking the jobs of people in local government. There are plenty of jobs that people in local government don't want to do, like writing parking infringement letters and collections and things like that, or sitting on the customer service desk and copying abuse from someone who's come in and had something go awry at their house. So it's not about replacement stuff. It's about finding better ways to do things. But if the information is not there, you can't do any of that. And I think this whole concept of just doing better with information systems, and the fact that it's everybody's responsibility, I think we're still a long way from that.
Yeah, and I think there's like sort of a surprising kind of amount that comes out of even a simple digital twin. And when I talk about a digital twin, like digital twin means a lot. It means all things to all people in some ways. But I'm specifically in this case talking about a 3D visual digital twin, and it's surprising how much can come out of just that is unexpected. And I mean, a good example would be that, we at City of Hobart, we put on a drone operator, and we took our own drone footage, and so we could get really lovely, high resolution 3D imagery of the city, which is still up there online. But the kind of use cases that came out of that were really surprising, and would never by themselves make a budget case for it, was, for example, the arborists were able to measure the height of any tree in the city, like any tree. They could just draw a line down it on the 3D digital twin, and it would tell them that was a 17-meter tree or that's a 23-meter tree. That data just doesn't exist, and it's really hard to get. But it was easy to get once you'd captured the entire city. And things like, does this roof produce, what solar yield will I get out of this roof? And that's useful to a resident or to a business or to a city or to whoever. And you can look at that roof 365 days a year, 24 hours a day, and see when it's actually in sun and do that analysis. That's a really expensive thing to get a consultant to come and do on one building. But having a digital twin there means you've got that for essentially the entire city. And that's, things that we could do. And it's not just about, at this latitude, how much sun do you get? It's about how high is the tree next door and the building up the road and which ones shade what. You can never get that information, any other way except through having this high resolution digital scan of the city. But the really difficult thing is bringing that information back to the people who need to use it. And it's really tricky to find, the person who needs to measure the height of trees and tell them, hey, by the way, we've got a way of measuring the height of any tree now, but I never knew you wanted to know that information, and you didn't know that I had that information. And so we did the digital twin really as skunk works, but once it was there, you could sort of sell the concept of it internally, and people would be amazed that this resource existed.
Yeah, great examples again. And I think, it really leads to the position that these things, like a digital twin, is going to create a lot of longitudinal value once it's created, but then, like any asset, maintained, nurtured, you know, utilized, all those sorts of things. And I think part of the challenge is to overcome is to get that project, but then equally for it not to be seen as this is a project for the 2025-26 financial year, and then move on. Why are we still putting $30,000, $50,000 a year into the digital twin? Well, it's not a project now. It's an organizational asset, and it can create a lot of value and help us solve a lot of problems and all the rest of it. I think digital twins are absolutely amazing and will continue to grow in importance, and as that sort of pane of glass for smart city programs and the underlying Internet of Things technologies and things like that. It's a wonderful symbiotic relationship.
Yeah. And I mean, the other thing is, I think there's kind of a limited understanding of what the digital twin is and can be. And some of the kind of experimental stuff that we were doing was to do thermal imagery of the city at night in winter. And you had got a completely new view of the city. Not only did you see, where the light was and how much, potentially sort of stray light there was from certain places, but because it was a thermal image, you could see which buildings were leaking heat out into the environment. I mean, that's such a massive, just a massively important piece of information for the owner of that building, and for the planet and for the environment and for the costs of heating and cooling and that sort of thing.
It'd be pretty handy if you're on a colony on Mars too, I reckon. Is that oxygen?
Yeah, that would be. Yeah, it's that plume.
Yeah, blame IT.
Yeah, but I mean, there was, and the other one that was never developed, just some initial tests done, which would have initial sort of proof of concepts done, was the underground digital twin, which was not only in a city like Hobart going through the rivulet, which is now buried under the city, which was really fascinating to see, but also using ground penetrating radar to start to pick up a 3D map of what's under the surface of the road. And that is really important information for anyone who wants to dig a hole, and usually involves massive costs and often involves cutting off half the city's internet because someone didn't realize that this thing was where it is. So, I mean, this, I think, even though it's a difficult project to get going, the idea of kind of a multi-dimensional digital twin, it was a really exciting one, and there was so much that was kind of really just below the surface.
Hey, you've probably got some really good ones. Is the American Meteorological Society or whatever? I don't know if you've been following the Hurricane Melissa
Well,
this couple of days, or you've seen any of those photos of the inside the eye
yeah,
and that concept of the stadium effect. Like when I saw that video yesterday, this plane flying in, and then whoa, that it's incredible. Like just that blew my mind. And so I imagine they have some pretty amazing digital twins of that sort of stuff as well.
yeah. There were birds trapped in there too, which was interesting. I
Well,
mean, yeah,
that would freak you out if you're a bird, wouldn't it? Like unless you could go up, like you just got to, you fly around in circles until it dissipates or something.
I think so. Or you run out of energy.
Yeah. Maybe that's why all the birds fall out of the sky sometimes in things. To just fall out of the eyes. But yeah, that stadium effect, oh my god. Absolutely incredible. The other thing you mentioned at the start, so yeah, you kind of left and you're now working for Firmus, which is a really interesting firm. Yeah, this whole concept of the immersion cooling stuff, immersion cooling technology, but also I think before that, just the fact that data centers, like the resurgence in data centers is just incredible in every country on the planet. And we went through a period after, the start of infrastructure as a service around 2009, where there was quite an explosion um, of them. But also there's been plenty of countries around the Asia Pacific region where the big hyperscalers haven't even put data centers yet. But now that's all starting to change as well. So just this whole shift where for a while there was a real lull, but now it's sort of come again. That's obviously to do with the AI space. That problem that data centers face in terms of as the compute gets more sophisticated and smaller and hotter, and the ability to, like, we almost out engineered the ability to actually run a data center. You're going to explain this a lot better than me, but then, so how do you fix that? And so can you maybe just explain to people, um, you know, the particular problem statement you're looking to solve? And then I know there's a couple of different sorts of immersion cooling and things like that, and just like where it's at, because it's fascinating what's going on, because it's going to actually save a lot of assets, and um, there's a lot of money in terms of people's superannuation money too invested in property portfolios and data centers. And if they were to become defunct, that would be a real problem. So there was a challenge there for a while that, like, how do you retrofit and continue to expand and grow data center capability once the technology has sort of outlived its capability within those four walls? And so the ability to sort of continue for these capital not to be destroyed and for the industry to continue to grow, this was a really sort of important physics problem to solve, right?
Yeah, I mean, God, there's so much to unpack in that question, but um, I mean, the problem statement, I guess, to start with, um, for Firmus, and this is a few years back, was that in general, most data centers run on a PUE of 1.5, right up to even up to 2. What that means is that for every kilowatt hour of energy that you use for compute, 1.5 means that you're using zero 0.5 of an hour just to cool the machines for computing. So that was generally how data centers were up till a few years ago. They were all air-based, so you would just be blowing massive quantities of air and then cooling that air using some kind of air conditioning system, and then blowing that through the machines, cooling it, blowing it through the machines. So you're trying to strip this heat away from the machines so that they can continue to operate, within their temperature range.
Because there's a lot of compute going on.
There's a lot of compute going on. So the GPUs, the CPUs and the GPUs are producing most of the heat, and now it's GPUs with the big AI machines. And if you want to get a sense of, what they're like, if the GPU is only sort of 50 by 50 millimeters, it's just a little square. But if you just turn that on and it wasn't going to blow up, it would be very similar to turning on your electric stove. Like it gets that hot. There's that much heat dissipation coming off. So if you had a little tiny kettle, you could even boil your little kettle on the GPU. So they get really hot. So you've got to work out a way of getting this heat away from there. And traditionally that was to blow air through and to have a big heat sink piled on top of the GPU that would pull the heat off the GPU. The air would take the heat away from the heat sink, and then you just continue that cycle. And so
Old data centers always sounded like typhoons.
yeah, I mean, they sound just like, if you go into a big data center working flat out, it's just like being in an airport. It's just like jet engines. And these small fans running at very, very fast RPM, they're really noisy. So the first stage of Firmus's development was to take that entire computer, everything, like the whole server, and just run it in oil. So the whole thing was just sitting in a bath of oil, and then rather than trying to blow, and oil has, at least 1,000 times better heat dissipation than air. So you could pull this kind of heat away, moving the oil at 1,000th the velocity of the air. So to get the same amount of heat away from the GPUs, we just needed these pumps ticking over, pumping very slowly, and then that heat would then be dissipated. And we had, in general, we are trying to use low energy methods of dissipating that heat as well. So sort of using dry coolers and rather than air conditioning systems. You can use evaporative coolers. That means your water use goes up. So if you want to keep your water use down and your energy use down, then your best option is like a dry cooler, adiabatic cooler, it's called, which is car radiator. You're not evaporating your water away, but you're kind of blowing the air across the water, across.
Well, stripping out more heat more efficiently, but would it equally take longer to cool?
No, so we could cool. I mean, you might need a bigger heat exchanger, so you've got maybe more surface area, but in general, this is like a very low energy way of doing it. So we could bring the PUE, the power usage effectiveness, from 2 or 1.5 down to 1.02. So essentially, instead of 50% energy sitting on top of what you're using for compute, we were like 1 or 2% on top. So very close to a rounding error. It's kind of a really nice way of doing it. And this is a really kind of, there are a lot of engineering challenges, in order to do this. But as the computers are getting more and more powerful, there's no technical reason why you can't keep doing this work in full immersion. And we are building new immersion data centers now. But the next generation of computers that are coming out of companies like NVIDIA are designed in a way that makes it essentially impossible to immerse the whole thing, but they're built in a way where they have liquid cooling built into them. So they pump water through the GPUs and they take the heat away, and they get pretty close to immersion cooling in terms of the sort of overall effectiveness. And so with Firmus, we will bring our compute, like Tasmania is an example, to a place that's naturally cooler, so it's easier to cool the machines, and uses 100% renewable energy in the grid in Tasmania. So that's, as we sort of evolve into these new machines that can't be immersed, but they can still use liquid cooling technology, we have adapted our cooling systems to now work with water instead of oil, So we're doing very much the same thing, just cooling the water instead of cooling the oil. And the important point you made was, what happens as you outgrow the space? What do you do with this real estate? And that's why we sort of have this. Um, Look, our engineering approach is to build a data center that will take today's or for the foreseeable future larger and larger heat loads using the same cooling infrastructure. So we're sort of massively overscaled for today, not at a massive extra cost, but we massively overscale. So you can bring the next generation of computers in if you want to or need to, and still maintain all the same real estate and the same cooling technology and everything. It'll all still just re-plug in. So that's kind of where Firmus is. So Firmus was really a world leader in immersion technology. We're now sort of in this space where we're doing liquid cooling in a way that's on a different scale to most other companies, which we think will give us an edge, particularly in terms of the sustainability of those data centers.
It seems like to me this is just an area that hasn't got enough attention, or there hasn't been enough talking about it, because the underlying challenge here is that our consumption of compute continues to increase exponentially, and therefore the heat signature continues to increase, maybe not exponentially, but to a point where the global infrastructure that has been built over the last 15, 20 years will essentially, unless it is retrofitted, be incapable of meeting the computing requirements that the world now needs just to run. Now, to me, that sounds like a problem. Like it's not building the ark problem, but it's a running out of runway problem. That if we do reach that point, what starts to happen? Now, the fact that it's happened at the same time as AI has exploded and continues to explode exponentially, that kind of feels like now we're throwing kerosene on the fire that nobody's talking about in the first place. So, and we'll sort of bleed into AI in a second, but is it? Does it seem that way to you? Like that this is
Yeah, I mean, it definitely does. I mean, I'm reading about. Sorry, yeah, it does, and I'm sort of reading about data centers that are being built now where they're buying essentially surplus jet engines, from defunct aeroplanes, and turning them into generators to power data centers. I mean, so some of the stuff in the US is mind-boggling just in terms of scale. Just I mean, the scale is really hard to get your head around. And I mean, a nice way to think about it would be that, say, in Australia, most houses, so your house, you probably use about 24 kilowatt hours in a day. So most domestic houses, maybe a little bit more, but most domestic houses are using 24 kilowatt hours in a day, which means that you're using about a kilowatt hour every hour. And so, sorry, which means that you're using a kilowatt
every hour.
all the time. So percent of the time, averaged out, during dinner you use a lot more when cooking, but at night you use less. But on average, you're using about a kilowatt to run your house. All the stuff you do in your house, you're using about a kilowatt. These computers, the racks that are the new like NVL 72 racks, for instance, it's a 72 GPU system. That's kind of what NVIDIA sells now as a unit. You roll in one of these racks. They're getting sort of up to 140 kilowatts per rack, and the next generation's 200 kilowatts per rack. So essentially you're talking about 140 or 200 domestic houses per rack. And then a data center is going to have 256 or 512 of these racks. So the scale of the amount of energy that's required is absolutely mind blowing. If you think you've got 200 houses times 512, and then all that's doing is producing tokens, which is the units of AI meaning, and generating a huge amount of heat in the process. And it's interesting too, because this gets back a little bit to some of the stuff we were talking about with cities, about being able to talk to other people who are users of similar infrastructure and do some working out about, how to do things in conjunction with each other. In some countries, particularly around countries in Europe, I think, even Russia and Mongolia as well, they have this concept of district heating loops, where if you've got an industry that creates a lot of heat, rather than trying to dissipate it, you pump it into hot water, and then it gets pumped around, and anyone who needs hot water, which is everyone, swimming pools, industrial users, domestic users, everyone wants some hot water. So you have a hot water pipe coming into your house rather than just the cold water. But
Man-made thermal springs
yeah,
for everyone. Yeah.
and so
Kind of sounds like you'd need a fairly forward-thinking government to be doing, which we're a bit short on these days. Like you
we
don't.
are. I mean, it's really sad. I mean, these were all built into a lot of European cities in the 60s, but there was never a consideration in Australia.
Well, this is another part of the conversation that we're not having. I think I'm seeing bits and pieces of different parts of the story appearing across the media. Like the energy consumption story is popping up a lot more frequently. Like there was a story a couple of weeks ago about how Microsoft has bought all the forward contracts for every single kilowatt that will be produced out of the 3 Mile Island nuclear facility for the next decade. Like everything, like nothing will go to the state in which that energy is produced, because it's all going to go to power the Azure data centers, which is astonishing, like absolutely astonishing. And if you play that out across the rest of the world, just across the hyperscalers, and then across, all the contracts of supply guarantees that all the new AI vendors will need, before we even get to the private data centers and the rest of the world and the electricity to power our houses. And the fact that for the last decade, all we've been talking about is, having a reliable grid, which Australia is struggling to maintain. Again, it just seems like we're having bits of the conversation at different, without actually stepping back and going, what is actually going on here? So it just seems really strange to me.
Yeah, and I mean, and I think that problem will continue until one of two things happens. One being that we get nuclear fusion working, and I think, there's sort of an outside chance that will come more quickly because of AI, which would be kind of an ironic twist, but we'll see.
In terms of telling us how to fix it and do it.
Yeah, I mean, how to build a tokamak in a way that'll actually work rather than sort of work. Or the other thing is, someone works out how to run high performance computing on orders of magnitude less energy. And I can't necessarily see that happening, but it's pretty bizarre that the human brain runs on about 20 watts and it's doing sort of similar level of processing to a 20 megawatt computer.
Well, I mean, dangerous space. The first person to come up with that, if they have that sort of intelligence, they're not telling anyone, because they're going to be disappeared by the CIA.
And I often thought about that. I was thinking, if you had been, OpenAI or whoever you sort of got the first large language model going, there must have been a lot of conversations around, do we release this or do we just become
Yeah. This, like, we are at the end of the chain. Like, you're a super smart dude, but we are at the end of the chain in terms of the things that are going on this planet. Like, we just know there has to be solutions to some of these problems that extend beyond the oil wars and things that we've had for the last 100 years. But we do need answers to these problems. And I think, we'll see more of it. Hopefully we'll have more of these conversations, had publicly, because it sounds like we're moving past the point where there was a real danger of a capital collapse around just the equity investments into data centers around the planet, and the fact that, okay, well, if they can't do what we want, then they're going to be massively devalued. And okay, it looks like we're finding ways to solve that problem so we can move on. There's not going to be a global financial crisis caused um, by our data centers no longer being able to keep up, pace with us. I am seeing some commercial messages come out about it, like Interactive is the company in Australia that actually market the fact that they're using immersion cooling, both direct liquid to chip and liquid immersion stuff within their data centers. So I think it's as it becomes, now we've kind of switched to we've solved the problem. Does it become a competitive advantage? And we know as soon as it becomes a competitive advantage, then the whole industry is going to go absolutely batshit over pushing it, and then we'll probably get more visibility and investment, and it'll be a big spike. But that doesn't solve the energy problem, does it?
No, I mean, there's an energy problem. There's in a lot of data centers, there's a water problem. I mean, and I think the jury is still out on whether there's a revenue problem. I mean, there are, a lot of questions over what the, in the end, who's the consumer for a lot of this compute. Because, a significant amount of it is provided free, and a significant amount of it is provided sort of at less than cost.
Yeah, yeah. But that's an interesting point. And I think maybe we're tipping over into the AI part of the conversation, because like data center compute has never been free. It's never been given away like it's given away with AI.
No, I mean, you store your terabyte of OneDrive information. You pay for that, like you pay a lot for it, and it's not really doing anything. It's just a hard drive sitting somewhere.
Yeah, there's like every CIO across the country will understand the term reserved instance, and that's essentially you're paying over the odds for every piece of infrastructure as a service coming out of someone's data center. So it's never been free. But to your point, a lot of it is at the moment because of this potential AI bubble. And the thing, for all the rationale around the arguments that we're in a bubble, the part of it that actually causes me to pause the most is the fact that whenever there's a bubble, there's always this little thought that this could go on forever. Like, it's not going to pop. Like, there's just so much excitement around it, and if you look back at all the bubbles, that's exactly the way it's been. So it's just the fact that it feels so intense, and how could it possibly end, which is probably, the biggest canary in the coal mine to say that there has to be a correction, because there is a massive amount of capital concentration. There is, as you say, there's a real disconnect between the valuations and the productivity that we're seeing out of it. And so, and in the productivity side of that equation, I would put cost, because you got to, like, is there a cost that people are paying for? And if they're paying for it, it's a service. And what are they using that service for? What problems are they looking to solve? We're starting to see some use cases, but very, very sort of like it's out of balance with that whole valuation. And then we've got this other problem, which is the massive inflation, that input inflation problem just around the GPUs, where the craziness is causing craziness in driving prices up, just like a housing bubble. And so, like, just the chip inflation sort of side of things is just ridiculous. And you can sort of, keep going and keep going, keep going, go, what is going on?
Yeah, look, I mean, it is. I mean, the other thing that is worrying is that redundancy issue that you talked about before. That something becomes obsolete within a few years. So I mean, if you look at the the progress of the NVIDIA chips, like the A100s, the V100s, and the H100s, and then
Can you talk about them for a little bit? Because NVIDIA is like one of these magic words that's thrown around, and everyone and NVIDIA do a lot of things, but when people talk about NVIDIA, it's usually about the chips. But I don't think there's a wide understanding about some of the differences and these chips. And you're sort of seeing it firsthand and it was publicly announced in terms of like Firmus being a NVIDIA AI infrastructure partner, and like a week or so ago. So what are these chips? What are these Wonka tokens that everybody wants?
I mean, I think NVIDIA was one among a few companies that kind of recognized that there was always a scale problem with AI where it sort of fell off a cliff when you tried to make it too big. And then there was a pretty influential paper that came out probably 10 years ago now, which talked about getting beyond that scale problem, which was as you brought the number of parameters up that you used to train your model, you would see diminishing returns to scale, and it started going off a cliff. So people would stop and try to get back to the beginning, and then there was this sense of what happens if you keep going beyond that cliff, and then suddenly there was this acceleration of sort of capability that happened as you made the problem space bigger. And so, I mean, it's hard to kind of describe in simple terms, but if you're talking about, you know what a number line looks like. So if you're saying I want to go from 0 to 3, you're just drawing an arrow along the x-axis. But then if you go into 2 dimensions, you might say 3, 5, and you draw a line out to that point. And you can go into 3 dimensions and you can say, 3, 5, 7, and you know that you're talking about a point in space. Well, you just keep doing that in an abstract way mathematically, where you can say that some point is off at some position in multi-dimensional space. So you could say that you've got 17-dimensional space and you define it with 17 numbers. That's some spot out there. And if you get that number of dimensions large enough, which is what you need to do in order to kind of deconstruct all of the knowledge that's ever been given by human beings and sort of written about, all this text, you can kind of bring that together and ask these statistical questions about it, but you only get, remotely sensible answers if you're going out into the billions of dimensions. So you're talking about a line that in your mind, you could just think of it a line from the origin to some point, but that point is defined by some number of billion dimensional points. So you need to have 7, 2, 3 for billions of numbers before you can say that's where that point is. And it kind of, in a really weird way, comes back to that point becomes like the point that defines Tom Cruise-y kind of stuff. And things that are near that point are kind of, Nicole Kidman's probably somewhere near that point, and then Days of Thunder is somewhere near that point, So there's this kind of area of this multi-dimensional universe where concepts live, and then pond slime is probably over here, and then all the things around pond slime. But if you haven't got a chip that can deal with these massive, massive, massive matrices of numbers, then you can never find those points in space. So you can't sort of analyze the language on any compute that can't run in sort of billion or multi-billion dimensional analysis. And so the winners in terms of the AI space were the people who could work out how to do that mathematics, and I mean, it's a very, very, very complicated version of the same thing that was on your Nokia phone, where you would write "Hi," and it might say "How are you?" or something, and you go, "Yep, that's the next thing I was going to write," and so it chooses that for you. But this is like taking into account all of the different things that have ever been said by anybody that happens to be available to the computer online, and then bringing all of that together. So statistically, there's a really high chance that the next word or phrase will be this. But you need a chip that can do like this massive parallel processing of billions and billions and billions of parameters all at once, and then you solve the problem that is the corpus of human knowledge in text form. So the first ChatGPT, I think, was built on NVIDIA A100 chips, I think, which was kind of about 4 generations ago. So this was GPT-3, I think, the first one that was public, was just built on this massive number of these NVIDIA chips, these GPUs. And the reason they used GPUs was because the same kind of compute that you needed to do this was very similar to the kind of compute you needed to work out where things were spatially in a video game. And NVIDIA had spent years developing these chips that were incredibly good at sort of processing these large matrices of numbers matrices of numbers that would be able to, let you drive a car through Grand Theft Auto or whatever. Working out where everything was in a fast enough period of time so that you had a realistic experience. So they became the kind of the engine that people needed in order to run these large corpuses of text through these systems. And then NVIDIA's progress since then has been through the A100, which is more of a graphics chip, through the V100, which was optimized better for text, then I think the H100, which is still a really powerful computer, but it's kind of that's the one that we use in most of our immersion environments. And then starting to get through to these Blackwell sort of chips, which is the present generation, which is similar to the H100, but just a much faster chip and sort of strung together in a different way. And then there's sort of 2 chips side by side, so you kind of double the power within the one chip. And all you're doing is increasing the size of that problem space that you can tackle at once. So that means you can get sort of more done more quickly in terms of training the model, but also you can sort of gain more insight and more exact locations of where things are in this kind of multidimensional universe, because you can run these relatively straightforward mathematical algorithms on these chips that are bred to do that. And then the next lot coming out will be the Vera Rubin chips, which is a step up again. And then there's Vera Rubin Ultra after that. And then they go on somewhere. So the next 3 are kind of planned out. But each one becomes bigger, hotter, more power. And I think the H100s, the ones that we use, are generally 700 watts on a chip. The next ones, the GB300s, they're more like 1200 watts on a chip. And then the Vera Rubins are going to be 2000 watts on a chip or whatever it is. And whereas back GPT-3 land, the first A100s were maybe a couple of hundred watts on the chip, which is extraordinary for the time, but it's kind of very quickly become superseded as these new models come out. And I think that's where the danger lies, is you end up putting a huge amount of investment into a technology that maybe becomes obsolete after a relatively short time. But there's not quite the risk that it seems, because there's still a lot of use for.
Yeah, it's amazing technology. It seems more like it's the arms race component of it, which is the challenging thing to get our head around. And as like putting my tech analyst hat on, that's the most obvious part to everybody at the moment, is just the vast amount. Like, I say vast amounts, it's probably insignificant in terms of the amount of money they're actually spending on forward contracts for chipsets and things like that. But the amount of marketing dollars being spent to try to win ground in this land grab to be the AI platform for the enterprise, like today, to try to win the banks and the governments, and to say that we have the best AI platform, or we have the best, AI infrastructure. That's the bit that's really setting the world on fire. I mean, I think all these other things that are happening underneath, they're they're industry problems to solve. The energy problem is an industry problem to solve. The the sort of the usability and the utilization is an industry problem still to solve that we're not going to solve with marketing. I think that's the thing. If marketing can get closer to solving the utilization problem and focus less on winning mind share and the land grab for AI dominance, and we can get closer to utilization, then that at least takes care of some of the bubble problems, probably not the liquidity issue of a capital market where trillions of dollars are being poured into it. But even how does a company like Nvidia even keep up with the production demands of even having the best engineering roadmap that you could possibly have? How do they meet demand? And sort of be, and still be the keystone firm in this whole equation. And that's the stuff you're seeing now.
Yeah.
All these little images, which all roads lead to Rome.
And I mean, we meet with them quite frequently, and it's pretty astounding how nimble they are for a big company. Like you've got kind of today's tech, and you've got people concentrating on today's tech, and then you've got sort of these future focused things, and they kind of know what's coming, but the details aren't certainly not public, and not even necessarily clear internally, but kind of the path is well sort of mapped out. It's pretty extraordinary that when something is it'd be like having the first time you ever got a computer, you expected to keep that forever, when you're sort of in the 90s or something. And then you suddenly started to realize that every few years, the computer was kind of no longer fit for purpose, and so you'd have to update it and all that sort of thing. And that cycle is getting, closer and closer together. And the extraordinary thing is when you're talking about moving trillions of dollars of compute, knowing that in 6 months, everything's going to change. I mean, it's interesting. I went to a talk given by Google, and I asked them about how they dealt with that issue of things becoming sort of obsolete. And they said that, for them, there was this, internal, allocation of resources where some of the stuff that they were using 20 years ago is actually still in service, but it's doing these low value tasks. And so as the compute gets better, they just have, old things to do with the older chips, and then they move their kind of frontier of knowledge stuff through to the higher level stuff. And, they said that they will generally run things till they fall over rather than run them till they're obsolete and get rid of them all. And the amount of investment you have to make sort of in the real estate and the equipment, it really means that you've got to run it for a certain number of years, or you're just never going to break even with it.
Mm. Yeah, and I think that the difference between the haves and the have-nots in this space is astounding. Like, we used to think the digital divide was something to close, but it's like child poverty and homelessness, and it's just something that lives with us in terms of the access to these sorts of capabilities. And it's very difficult to imagine another foundational player coming into any space in computing in the foreseeable future, just because of.
Yeah, and I mean, I agree with that, but then I always imagined that there would never be sort of a way of, knocking Google off the perch. And I'm not suggesting that anyone has, but it's pretty quickly transforming from doing a Google search to just asking an AI. And the AI goes and does the search for you and gives you an answer. And so Google's cottoned onto that, and obviously it gives you an AI answer. Which to me, I think is really sad, to be honest. But that kind of AI tidal wave even shakes sort of a behemoth the size of Google, where they suddenly realize that all that ad revenue from searching could very quickly move elsewhere.
Yeah, it certainly does, and Google is fascinating for that reason, for a number of different reasons. One, they missed cloud computing. Like, they're still considered to be one of the 3 top hyperscalers, but they're distant third, and, they are coming back stronger, now, and the things that they're doing in the AI space in terms of, some of the agentic AI capability that they're releasing, it definitely puts them on the day one list of that. When we're talking about utilization, we're really talking about, okay, applying AI inside the enterprise. And okay, now we're talking about not just, providing LLMs to our staff, but the way organizations are going to transform with the use of agentic AI as well. And so they're certainly playing a stronger hand this time around, even though they probably missed the last wave.
It's interesting because I'm yet to be impressed by agents, and I know a lot of people who have been sort of wowed by them. I'm yet to find one that actually fulfills in the promise that it'll do what it says it's going to do. It often says, "I'll do this for you," and then this, and then this, and then this, and then I'll say, "Great," and then nothing happens.
I think this is the smart city problem, though, because it's everyone agentic has been pegged as the thing, and now everyone's in agentic, when in actual fact there's only a core few that are doing it. So everybody, every software company is now saying they have an agentic solution, and they don't. Most of them are crap, but there are a couple of, really solid platforms. ServiceNow is a perfect example where it's been architected from the ground up to be a true, multi-persona, multifunctional agentic platform. And I think that's the key, because if you want something to be agentic, then you're not just you want to interact with it almost on a human level. So you're not looking at for it to solve a single functional problem or a siloed problem. You need it to be able to interact with another system or other agents, because, you would typically look for capability across an organization to pull together an answer that you need to the problem that you're having. So that's the problem. If independent software vendors are releasing agents and they're functionally specific, it's just going to be, a fancy chatbot. It's not actually going to provide any of that human-like capability. That's why that land grab is so, important, and sort of talking at the levels of the IBMs and the Accentures and the ServiceNow and the Salesforce and all those sorts of organizations, because it does solve problems, but everyone can't have a great agentic solution. It's just
Yeah,
they don't, but they tell you.
I think one of the interesting things about the AI sort of space is and not sure what I think about this, but there is that it's the extraordinary level to which it came out as a democratized solution. Like anybody can get access to it at some level, and so you've got AI doing sort of protein folding experiments and trying to sort of decode the Herculaneum scrolls and sort of create a better tokamak fusion reactors and that sort of thing. But then you've also got it creating cat videos and sort of running political bot farms. Like there's this weird sense that there's this kind of, I mean, in some ways it's just a statistics engine. The worrying thing I keep coming back to is wondering whether we're just statistics engines because it's so like us. But anyway, it's just a statistics engine. But at the same time, it's this super intelligence doing things that, in science fiction 40 years ago, people thought this is what AI would eventually do, solve the protein folding thing. But nobody really thought it would also become this kind of meme generator or sort of political actor. The really fascinating YouTube video I saw the other day about the time when Elon Musk was trying to tune Grok to provide the kinds of answers that he wanted it to provide. And then for a sort of 1 day period, it started calling itself Mecha Hitler, went into this world domination spin, and it just became really clear how impossible it was to kind of contain it. Such a
Yeah,
Pandora's box. You sort of open it and it's out. That's it.
It has, like every technology that's ever changed the world, its implications are really unknown yet. I mean, we're only seeing the implications of social media play out, 20 years after it first started to come out, and
Mm.
all these all these rollbacks for young people and recognition amongst people our own age that this social media has been has had a number of disturbing effects on people's mentality and social evolution and and all those sorts of things. And it's probably going to be exponentially more problematic with AI. But this is the intergenerational shift. And as Gen Xers, how do we not sound like Luddites to our children who are the next generation of architects and engineers and are fully capable humans, but they live on social media cat videos as well. Like it's kind of, I keep my fingers crossed that I'll actually be a real grandparent one day. I mean, there's all those implications around how technology is leading to global depopulation and what that means. And maybe AI is here to save us eventually from ourselves, and that'll be the next life form.
I don't know.
Who knows? Who knows? We're still close enough to the 20th century that all those same sort of economic challenges of booms and busts and bubbles and trends and everything, they're still familiar to us, even if the implications of the technologies aren't.
Yeah, that's very true. I mean, I tend to just keep up by watching a lot of cat videos and things. you, it's quite extraordinary how that generational shift has happened extraordinarily quickly.
Yeah. Well, I do communicate with my daughter in cat videos. It is our common language, so I'm not against it. I think that what happens in the next couple of years is going to be absolutely fascinating, and for me, that's that's one of the most amazing things about this era. Like, technology has actually been pretty boring for the last 15 years for all the transition to as a service. They've just been literally that transition states to something else. And I think that's something else that we've been waiting for is now. It's this new platform as a service era. It's AI driven everything. And so technology is really, really exciting again in a way that I haven't seen for a very long time. So it's it's an excited trepidation that we're all trying to figure out. And I talk to a lot of tech execs. No one really understands what's going on. And there's a lot of hesitation economically around what it is that's going on. And so we're just living through it. Like, we're the frogs in the pot, and it'll make sense in retrospective. But the other thing is, probably we'll be well retired, sipping our red wine, hopefully by the beach. But the next wave of computing is coming too, with quantum, in terms of, like, that's it's accelerating slowly, sure, but that's what does quantum plus AI look like? I mean, oh my goodness.
I mean, I saw some really interesting news this week about sort of breakthroughs in quantum technology, which I assumed would be many years off, but it seems to be moving faster than I expected. I mean, I think you're right about it being exciting again. I often think about, like, to me, it's a really extraordinary thought that you could be 10 years old and have watched the Wright brothers take off, and then be in your 70s and watch Neil Armstrong land on the moon. I mean, that was a really bizarre period of history. And I think things have moved, quickly since then as well. But living through them, you don't get the sense of that acceleration quite so much. But I really have felt it in the last, 5 years, thinking of all the shares I didn't buy more than anything. But you just think,
Now, Back to the Future is that's one of my favorite movies, and I wouldn't be betting on horses back then. I'd be buying stocks.
yeah, for sure. Yeah, no, it's bizarre. Yeah, I mean, I don't really know where quantum's going to go. I mean, it's designed to solve different kinds of problems. The thing that worries me is someone getting it who shouldn't have it, and suddenly we don't have passwords anymore.
Yeah. But that's what I mean, some of this stuff, we're just sheeple. We're we're out here at the end of the line. Uh,
Yeah.
and, we just hope some sensible people get to maintain their seat at the table for a while. It's been one of the it's been well known for years that the world's largest software companies have employed sociologists and professors of that to make software super addictive for us, as opposed to helping us really solve problems. I think, the exclusion of thinking about people as part of the end state for some of these technologies, as opposed to just making money, you know, is is a valid question, but something beyond our control. It can't
Yeah.
be regulated. We just have to hope.
Yeah. It's interesting. And I mean, no one's that, I mean, I don't know. Some people probably are, but you feel like no one's immune either. You kind of feel like, you're a Gen X sort of long form content person who grew up, reading but you get onto a scroll, of YouTube shorts or something. It just takes you like people have worked out that format, that sort of constant dopamine hit just works. And I just feel, dreadful for 7-year olds who just, that's your kind of first sort of, yeah, foray into, content.
Well,
I heard someone,
imagination,
yeah.
and time and space and just being able to breathe. I think it's a really interesting observation. And I've certainly tried to stay connected with reading, but it is challenging today. Whereas there was a time where I could spend all weekend reading, and I have to commit to it now, and I still love it, but it's different. So
Yeah, no, I feel exactly the same. I remember reading The Secret History in one day when I was about 19, and it was just one of those days where nothing else was on. I didn't have, we didn't have a mobile phone, and everyone left you alone. You just sit in the backyard and smoke and read.
are you stealing your father's cigarettes again?
I was living in Annandale, I think, at the time. It was nice sitting up by the compost heap. But I heard someone the other day saying something really interesting about how we keep moving the goalposts for what we call artificial general intelligence. And so artificial general intelligence, like this idea that you'd have a computer that is fundamentally intelligent and has agency and has, whatever soul or something, a consciousness. And that he said, if you think back to what we would have called AGI in the 80s or the 90s, we're just 100 miles past it. But we just decided, no longer, we're not going to call it AGI. We're going to say, no, where's the AGI breakthrough? You kind of get that sense there is kind of a very fuzzy boundary.
Yeah, well, I mean, our own Nostradamus in this space, Ray Kurzweil,
Mm.
who has, arguably got just about everything right for the last, well, since the 70s or 80s or whenever it was that he first started talking about this stuff, has said 2035. So within the decade, now, whatever that looks like, who knows? But that's pretty close to my retirement age, or what has typically been my retirement age. Sometimes I sometimes just hope that the world doesn't change so much that I'm actually, not retired within 2 to 3 years, because I never wanted to be someone who retired. I always wanted to stay busy, and I think that's part of the argument that a lot of the protagonists talk about with AI, that it will give us an opportunity to get back to having time, to being creative, to work on interesting things. But I think there's a real challenge, though, if there's one or two generations in between that have actually had time taken away from them, have lost the ability to, be self-driven, to spend time in their own imagination, to be creative, to walk outside, to draw, to read, to create, to, do all these things. You could lose it. You could certainly lose it. And so what do if that's suddenly thrust upon you? Not everyone's going fishing again. So
No, I mean, yeah, I don't know. And I think the point you made before about having to kind of, you know, having to sort of force yourself into those kinds of states where you're sitting down and reading or taking in long form content. I mean, I find now that I will tend not to just, listen to music anymore, where it used to be like 90% of my time. Because, I'd sort of think, oh, well, I'll listen to something interesting on YouTube, political discussion or, whatever. Just because there are so many content options that the idea of sort of sitting there and thinking about your own stuff with some music in the background just seems unproductive or something.
Yeah. Yeah, you have to make time. I use the time either if I'm going for long drives, I do work on the west coast of Tassie, and I always look forward to that because it's essentially a 4-hour drive there and a 4-hour drive back, and I can generally get through a couple of albums, a few podcasts, and really sort of enjoy the time. Or as both my kids have gone through the whole learner driver experience, and you've got to get up the 80 hours. Well, part of the trade off is it's dad's music, and dad gets to red or blue pill you with his podcasts, and it's kind of like a new kind of quality time. But
I think for those kinds of reasons, my daughter can't drive a manual car. Well, you take me. Yeah, I mean, something I've found really great on those drives, which I go up to Launceston quite frequently, is Audible. So those sort of talking books, and I've just started listening to the Lord of the Rings again. That's just a wonderful place to be. You're suddenly in Middle Earth and
yeah,
about everything else.
one of my favorite. I've been reading an adjacent high fantasy series. It's by a German author called Michael Heitz, and it's called The Dwarves. And it's Tolkien inspired, so it's got dwarves and elves and Alfar, and it's in this place called Gantigar, which is sort of set out similarly to Middle Earth. But yeah, it's wonderful to escape into that. I think it's really important because it fires up different parts of our brain, allows us to think. I don't know about you, but it gets me thinking about other things as well, because I don't know, you turn off or you switch off, or it feeds you in a different way.
No, 100%. Kind of, and I find that like I'll just sometimes just flick on Spotify and just let it do its thing. And you suddenly realize there are all these great songs that you never heard from the 70s or something. So, yeah.
Well, once you've finished doing that, I'll have to invite you round, because for Father's Day, I was given the Lord of the Rings board game, but it does take a few hours to play, but it's pretty fun. So maybe we can do that
Yeah, I'd be right into that.
over some dark ales and some fine wines and some roasted mushrooms or something, or whatever it is. But
Yeah.
mate, it's always great to talk to you. I think you're you're perfectly suited for what you do, having such a combination of left brain, right brain, because yes, you're an engineer, but you're an English lit major as well, which I think is a fantastic combination of a really balanced way of thinking to bring to some of these sort of problems that we have to face today. I love talking to you. I love hearing about what your next adventures are. So yeah, I really appreciate your time today. I mean, do you ever write, or do you have your own, content anywhere? If people want to find you, how do they find you?
Well, I don't. I mean, it's all on my hard drive, and it's not online. It's not online. I used to quite a lot. Thank you. Those very kind words. It's funny. I was reading something I was writing probably 20 years ago, just the other night, and thinking, yeah, it's pretty good actually. But no, I should maybe think about taking the plunge that way one day. But no, at the moment I'm sort of a relatively private Gen Xer.
It's I was listening to a podcast a couple of weeks ago. It was Matthew McConaughey, and he was talking about how he's not that interested in AI, but he's always been a bit of a thespian and a writer as well. And he said he just wants his own private LLM, so he can put every single journal he's ever written into it, and he can just explore the depths of his own mind. And I thought, That sounds bloody wonderful. A little frightening, but if you're a creative person, then is it you have so many ideas, you write so much stuff, and yeah, there's things that I wrote 18 months ago. I go back and read and go, oh yeah, no, I remember that now. But you're so focused on moving forward and the next thing. It's
Yeah, I mean, and it is. I mean, just to bring things back round to where we started, that idea of the private LLM, I think that's probably pretty much next, where companies and cities and governments being able to deeply investigate in a private way, not in a public way, their own sort of deep data in a city like Hobart with 100 and whatever years of records, all of that being sort of exposed to an LLM gives you this incredibly rich way of interrogating Hobart. Whether or not it's all going to be done for good, I'm sure, but you kind of you can imagine being able to get a much clearer sense of the history of a place. I mean, if you could say what happened, how did this building get here, and you can learn about who bought it and sold it.
yeah. I mean, you raise an important point. I think there's definitely a benefit to when we confidently get to a place when the AI we're using can present factual data without bias, because I think, so much of what we get today, whether it's through, politics, even at the local government level or state or federal, or it's in the media or it's in from companies or whatever, there's an inherent bias because everyone's trying to get ahead or get their own position or whatever. That is definitely something that AI could be very, very beneficial for, to at least be a source of truth.
Yeah, and I think that's a really critical point, actually, the fact that there really is no algorithm for truth. So if you want true stuff out, you've got to put only true stuff in. Because if you were training your model on, you know, even Wikipedia, which is kind of dubious, I mean, a lot of it is quite factually correct, but dubious, and then social media and everything else, you're allowing that to kind of pollute your pool so that the answer you get out, there's no algorithmic way for AI to sort out which one of those two statements is true. It's just got to present both of them or a blend of them, or if you challenge it, it switches to the other one and that sort of thing. So that idea of being able to just put your historical records from an organization in, then at least, you're probably going to get a lot of councillors argy-bargying over time or whatever, but at least your your source material is sort of pure source material rather than kind of sludge.
Yeah, yeah, and they won't be able to blame the officers.
I'm sure they'll find a way.
Not that it ever happens. I appreciate you, my friend. Thank you
All
very
right.
much, and
Thanks for the invitation.
let's do this again sometime.
Sounds wonderful. Thanks, Pete.